Hello, my calculus friends. I'm going to run through a few related rate problems. So I made a list of kind of things to do in class the other day, so I'm going to kind of follow that. So the first step is to check and see whether it's related rate problems or not. Look for keywords that give it away. Oh, actually, I'm not going to. I did that one in class, so I'm going to do this one. So as I read through this thing, it says the light is on the ground 20 meters from a building. So far, no clues. A man 2 meters tall walks from the light directly toward the building at that's supposed to be meters per second. I forgot. We talked about that in class. That needs to be changed. That should be a slash. Okay. How fast? Ooh, how fast? That right there is a key word. How fast is the length of his shadow on the building changing when he is 14 meters from the building? Okay. So here's the building. It says the light is on the ground 20 meters from the building. So here's the light. It's shining up at the building. There's the ground. There's a man who's 2 meters tall. And you can see the light shining behind him is going to cast a shadow on the wall. How fast is the length of the shadow on the building changing when he is 14 meters? So let's put some variables in here. So what variables do we have? We have the man walking, right? So his distance, this distance is changing. And actually so is that distance, isn't it? And as he gets further from the light, the shadow on the wall is going to change too. Because if he's real close, his shadow's real big. As he gets further and further away from the light, his shadow gets smaller. So we could call this like height of the shadow, so to speak. So we got some variables in there. I don't know which ones we're going to need or use or want. Let's also build our little ice box, because we'll get to that later, right? So now what we want to do, our second step is to write an equation that relates all the things I want to relate. So let's go back and see what we want to relate. It says, oh, the man is 2 meters tall. That's not changing, so I'll just keep that as 2, okay? He's walking toward the building at 1 meter per second. So what in this drawing is 1 meters per second? Well, there's a couple things. We could think of dy dt. That would be equal to negative 1 meters per second, right? Because it would be shrinking 1 meter per second as he walks. Or we could think of dx dt as positive 1 meter per second. Okay, you see that? Because his walking is going to change both of those things. Okay? Now it says, how fast is the length of his shadow on the building changing when he is 14 meters from the building? Okay, so that is in the ice box. We want to know how long, so that would be dh dt. How long is how fast is the length of his shadow on the building changing? So that's a derivative because it's a something that's changing. It's a rate. Okay, so we want to know that what is 14? So this is when he is 14 meters from the building. So that would be y, wouldn't it? So that would be when y is equal to 14. Okay? So we need to write an equation that relates y to h. Because we know dy dt, we want to know dh dt, we know y, and we could probably figure out h. Okay? So how could we do that? Well, we got a right triangle here, so we have some Pythagorean theorem stuff. We have a oh, hey, look at this. We know that the light is 20 meters, don't we? So we actually could turn that into, instead of x, we could turn that into 20 minus y, couldn't we? That's helpful, possibly. Okay. So now we don't even have to worry about x. We can forget about that. Nice. Okay. So now we need to come up with a relationship. So that involves y. Well, I know that, well, I have a right triangle, so I have Pythagorean theorem, but I don't know anything about the hypotenuse, so that doesn't help. But I also have some similar triangles in here, right? This little triangle is similar to the big triangle. So we could set up a proportion possibly where h over, let's see, h corresponds with 2, because that's the 2 rises. And then the run would be, under the 2, I'd have a 20 minus y. And for the h, I'd have this whole thing here, which is actually just 20, isn't it? So this would be a formula or an equation that relates my y and my h's, right? And I got too much stuff here, so I'm going to get that out of the way. Now we drew that triangle. I'll draw a smaller triangle over here, so we still know about it. That's my 2 meters. That's my y, my 20 minus y, and my h. Okay. Now, we could take the derivative right now, or we could get that out of the denominator. So we could write this as h times 20 minus y is equal to 40. That's a little bit cleaner. Now let's take the derivative of both sides. So the derivative of 40, of course, is 0. Derivative of h is dh dt times 20 minus y. And then we are, plus, we have h times the derivative of that, which would be negative dy dt. And that's all equal to 0. Okay. Now we've written our equation. We take derivative, and notice we didn't set it equals 0. We just took the derivative of 40 and ended up being 0. Okay, so don't confuse that. We didn't bring in the 0. That was part of the formula already. So now we got to do is plug in all the stuff we know. So we know that dh dt is the thing I'm looking for. So that'll stay dh dt. 20, of course, is 20. Y is 14, so actually I could just put a 6 in here, couldn't I? H is, what is H? Well, let's use this information to find out. So, so I just accidentally turned the recording off. Not sure when I did it. So again, we took a derivative, and we're plugging in things we know now. So we plugged in 14 for y and got 6 there. And now I'm trying to find h. So I would put h here over 20 and 2 there. And in place of y, I'm going to put 14, so that would be a 6 there. So that would be h is equal to 40 over 6, which is 20 over 3. So I'd put a 20 over 3 there. And negative dy dt, well, dy dt is negative 1, so a negative 1 would just be 1. So that really kind of disappears there. So then dh dt is going to be equal to a negative 20 over 3 when I move it over, divided by 6. So that'd be a negative 20 over 18, which is negative 10 over 9. So the change in the shadows, the change in the length of the shadow would be negative 10 over 9 meters per second.